Hi guys, so this little video is due to replace our CPD that we had in Hull in July. See, we had lots and lots of software issues with laptops, and however, I thought I'd just make a video so you all can have a look at and take it from there. So enjoy the activity. So what we're going to do is we're going to do a simple circuit, but we're going to do it with 3 bits of software. At the CPD session, it was only going to be 2 bits of software, which would be the Crumble software and the Make Code software from Microbit, for the Microbit. However, for this video, I'm going to use Tinkercad as well to code a Microbit from Tinkercad website and download it. So it's quite a good tool for getting something to work quite quickly for showing pupils, both Key Stage 2 and Key Stage 3 and beyond Key Stage 3 too. So let's start. So first of all, I have already logged into Tinkercad. I'm going to go to Create, I'm going to go to Circuits, and I'm going to open up a new Tinkercad circuit. So quite simply, because we are coding a servo, we need to connect it to the microbit within Tinkercad. So literally, I'm just dragging over a microbit and just place it just off center because the code and the software, when you open it up, will appear down here. Right, so I've got the microbit, so I've got the microcontroller. I will put the servo in, and I'm going to connect the input of the servo to the output of the microbit. Now to do that, I'm just going to use the connection wires, and I'm going to start with a black wire, and I'm going to connect the ground. So the ground is 0 volts or negative voltage, and I'm just going to make it a little bit neat. I'm going to bring it down this way to avoid any bottlenecks of the wires, just to make it really, really neat. Bring that there, pop that down there, and bring that down there to ground. Now, you will see that on the servo, the ground is a brown wire. Okay. Now, if I change this to red, what I can do is I can connect, change it to red, I can connect the 3-volt connection. See what I've just happened there? What I've done is because I've connected the 3-volt, that was connected. Right. I'm now going to connect the 3-volt connection to the 3-volt connection on the power connector for the servo. So I'm going to change this to red. I'm going to grab the output from here, and I'm just going to bring this round here. I probably will have a crossed wire, but there's nothing I can do about this. But because it's a connection on Tinkercad, it's not going to make that much difference. I'm just going to spend a bit of time just squaring these a little bit off a little bit, just to make it a little bit nicer. So I've got the ground connection, I've got the power connection going in the 3 volts. And now what I'm going to do is I'm going to get a yellow wire, and I'm going to connect the output 0 to the signal wire, or the signal connection of the server. So I've now made the 3 connections to the microbit. If I go into code, I can, well, do this simply to start with. Just going to get on button A. So when button A is pressed, we're going to get the servo to work. So if I go down to output and go into rotate server, I'm going to start on 0 degrees. Then what I'm going to do is I'm going to quickly put a pause in. Now I think it's worth adding a slight pause or wait command, because it gives the servo time to complete its tasks before it moves on to the next task to do. So I've got rotate servo 0 degrees, so that's going to go with the 0 position. It's going to wait for a second, and then I'm going to go back to output. I'm going to drag over rotate servo on pin 0, and I'm going to move that to 90 degrees. And then what I'm going to do is I'm going to put another wait for a second. And after a second, what I wanted to do is to go back to the 0 position. Now I can just go back to output and drag another digital pin, but also I can duplicate these blocks. Don't want those, so I can take it and delete those ones, and there's my piece of code. So if I simulate it, so I press start simulation, okay, nothing's going to happen until I press the A command. As you can tell, the servo is rotating at 90 degrees. Now, to download the code from Tinkercad to the Microbot, I've got a Microbot, which is here. I'm going to plug in the download cable, like so, and then I want to download the code. So to do that, I'm going to stop simulating. It's already said select the device. I've got a Microbot there. If I press download on here, what it should do is download the code, which is there. So I will need to go to the download folder. And if I just bring this to the screen so you can see it, bring it up here. So that is the Microbot code from Tinkercad. What I am going to do is to find the Microbot on here, which should be just like an external drive at the bottom. And I drag that piece of code from downloads onto the Microbot, and the Microbot is now being downloaded. And that's how you use Tinkercad. The downloads folder that opens up, I'm going to drag the code from the download folder, and I'm going to place it onto the Microbot like so. This is where we use the Make Code website for coding a Microbot. Now, obviously this is just immense and there's not enough time to go over it and stuff, but just to create the servo to respond to the A button pressed, this is how we code it. So if we go to new project, I'm going to give it a name. I'm just going to call it Servo. Press create, and then this will open up the website for coding a Microbot. Now, as you can tell straight away, on the left-hand side of the screen, there is a Microbot, so you get a simulation straight away. Right, now, if I just drag away on start, and I'm going to get rid of forever, just to clean the coding environment up a little bit, go to input, I'm going to use on button A, so it's a similar command as what I used with Tinkercad. I will go into, there's no little sub-menus there for servos. What I need to do is go to advanced, go to pins, and then I've got 2 blocks of code at the bottom, which is servo write pin 0 to whatever I want it to be. So if I drag that into the on button here, the logic behind this is exactly the same as the Tinkercad circuit. When I press the A button, then the servo should go directly to 0. I'm going to go into pause. I'm going to pause it for 1 second, which is 1,000 milliseconds. I can go back to pins and add the other bits of code in, or I can right click and press duplicate. Here I can just duplicate one piece of code, which is good. So if I type in 90 degrees, duplicate the pause, and then duplicate the servo right pin 0. Okay, I've got the piece of code there. Okay, now if I simulate the actual code itself, I can press the A button and the servo moves to 90 degrees, then it moves back to 0, which is what I wanted to do. Now to download the code, the microbit is still connected to a USB cable. It is just a case of pressing download. The microbit is connected. If I press next, I need to go to pair, select the microbit from here, press connect. Now that my individual microbit is connected to the Make Code website, press download, and that code is now getting downloaded the microbit. It seems to be a little bit slower than TickCAD. However, you don't have to go into different subfolders to get them. I'm using a microbit version 1, and what I had to do is to update the firmware. If you've got old microbits and want to update the firmware, get in touch with us and I'll show you how to do it. It's dead straightforward. And my code is downloaded. Right, just going to use a little bit of blue tack. I'm going to stick the microbit in place there in the middle of the screen. And what we can do is connect the servo up to the microbit. Now, I'm just going to make this a little bit bigger so we've got a little bit more space around here. Right, so first of all, we're going to have a look at the servo. Now, the servo, as it is here, we can see we've got the 3 wires. We've got the yellow, which is the signal wire. We've got the brown, which is the 0 volt or the ground wire. And we have the red wire, which is the positive power supply. So in this case, it would be a 3 volt supply. On the servo itself, the servo, inside there's a compound gearbox and a really tiny electric motor, and that produces quite a lot of torque for the size that moves that armature. So if I just place that there, all right, we need to connect this to the microbit. Now the easiest way to do it is to use one of these Redfern Electronics, these are called Crumbleizers, and quite easily we insert Crumbleizer into the connection for the servo, and that allows us to use the crocodile clip wires to connect the signal to port 0. We connect the positive connection to the 3 volt connection. I'll just move that down so we can see. And then the negative connection, or the 0 volt connection, to the negative connection of the Crumbleizer. Now that means that the servo is now connected. Now it's already connected through its power through the USB cable, but what I am going to do is I'm going to place an external power connector onto, or battery pack, to the microbit itself. Now what should happen is when I press the A button, it should work. And as you can tell, because I've pressed that button a number of times, press the A button, then it moves. Okay, and that's the 90 degree movement we get from the servo. Okay, connecting the Crumble to the laptop and the servo. So first of all, I'm going to put the trusty bit of blue tack back there, place the Crumble on top of it, and I'm going to plug in the USB cable into the Crumble. Okay, so very similar as the microbit, apart from one little difference. Got to put an external power supply to the Crumble itself. So connect the negative to this negative rail there, and positive to the positive connection on the power pack. Now this now means that the Crumble has got a power supply going into it. The power from the laptop through USB might not be enough to actually power the micro server. Now, previously in the Microbot connection, I connected the servo using a Crumbleizer. It's done exactly the same way for the Crumble. So the negative, I'm going to take it from the negative connection on the Crumble, positive connection on the Crumble, and then the signal wire, I'm going to put the signal wire into A on the Crumble, and we're now all connected up. Now you may notice the difference on the Crumble code that I'm going to produce, not using the downloaded software on the laptop. I'm actually using the Crumble online web software app, which is exactly the same as the downloaded programs that you can install on computers. So to create the code, I'm going to drag over program start. So I've got program start that I've added on. I am going to just zoom this up a little bit just to make it a little bit easier to see. Right, okay, so I've got program start. For getting it to move, well, I haven't actually attached any switches to it, so I'm going to get it to move automatically. I'm going to create a do forever loop. And then what I want to do is go into input output. I've got the code for the servos. I will drag in servo, which is connected into port A. I'm going to get that to be 0 degrees to start it. I'm going to go to basic. I'm going to get a 1 second wait, as I did in the Microbot code. I'm going to duplicate those bits of code. And first of all, I'm going to get the servo to move to 90 degrees. And then I'm going to duplicate the code again. And I've got the servo A going to 0 degrees. So that means it's going to move for a second, going to move to 90 degrees, and then go back to the start. Now, to run this, if I press the play button, you will see the movement being repeated from the code from the Crumble app. If I connect the servo to a little linkage mechanism, so the linkage is connected to a slider, and if I place it in this little bracket, now these brackets you can find on Tinkercad library, something that I just designed to hold mini servers. If I just press play again, you can see how there is a tiny bit of movement there on the servo. Now if I flip the design over, what you can see is that the eyes of the little ghost is just moving subtly. Now this can be changed by adapting the linkage or the position of the arm on the servo to get different movement along the slider. I hope this has been really, really interesting to watch. Have a go and see what you come up with. See how you can adapt it to use within Key Stage 2 and Key Stage 3. Get the kids to have a go as well. It's brilliant using servos. Use other good components with it as well. You'd be amazed at what kids can actually produce. Thanks for watching and listening.